It is my pleasure to introduce our wonderful speaker, Konstantin Gerbig, who is a graduate student in Yale's astronomy department. And he is going to be talking about planets in our solar system, as well as a lot of other more exotic planets that lie elsewhere in our galaxy. So yes, take it away, Konstantin.
Hey everybody, thanks Tiger for the nice introduction. My name is Konstantin, and give me 1 second. There we go. Setting up my Zoom. All right, yeah, my name is Konstantin, and I'm excited to talk about planets in our solar system and also beyond our solar system. So here's a brief introduction on me. My name is Konstantin. I'm an astronomy or astrophysics graduate student at Yale, and I'm actually from Germany. Maybe you can tell by my accent. And here's two pictures of me, one inside and one also outside. And as you can see, I'm in fact smaller than Earth, unfortunately. But maybe one day I'll grow up and be as big as Earth, and then I'll move the same amount that Earth is moved by me, Earth pulling on me. So we'll see. Anyways, so you probably saw cartoons of the solar system a lot, growing up. And well, let's first start what the topics today are. So I want to talk about the planets and planets inside and outside our solar system. And I research planets because I think they are very, very interesting. And today I want to convince you all why they are interesting, and specifically why Jupiter is my favorite planet. So here's the cartoon I mentioned. Here's the 8 planets in our solar system from left to right. So from close in to the sun to far away, away from the sun. We have Mercury, which is the smallest planet in our solar system. Then we have Venus, which is very hot and has a very toxic atmosphere. And then there's our own Earth. Then there's Mars, where humans may or may not travel to in the next 10, 20, or 30 years. Then there's Jupiter, which is my favorite planet. Then we have Saturn, and then we have the 2 blue gas giants, Uranus and Neptune. And this cartoon looks very pretty, but it's actually wrong for many different reasons. There's many sort of inaccuracies with that cartoon. I hope to show you today a few. But one of the things this cartoon gets right is that the planets indeed look very, very different. For example, here is a comparison of Earth and Saturn. So we all know Earth, and maybe we all know Saturn. So Saturn obviously does not have water or like a land and clouds, but instead it has a big, very impressive ring going around it. But here the planets have those sort of the same size, but actually Saturn is much, much different, has a much, much different size than Earth. So to scale, it looks more like this. So Saturn is way, way bigger than Earth. And in fact, on the bottom right, you can kind of see 3 little dots, which are actually moons that go around Saturn. So here's Jupiter, and Jupiter is, again, my favorite planet. And I'm going to talk about 3 reasons why Jupiter is my favorite planet. The first reason, obviously, it's the biggest planet, which is very cool. So here is Jupiter compared to Earth. Obviously, it's so much bigger than Earth, which is impressive. And in fact, if I want to compare Jupiter to the USA, it's even more impressive, right? If you imagine the US would be on the surface of Jupiter, it would barely be, it would be smaller than this sort of red region you can see here on the surface. The second reason why Jupiter is my favorite planet is because it has a really cool looking atmosphere, which is very interesting. So in 2011, the European Space Agency sent this spacecraft to Jupiter, which is called Juno. And since then, Juno has been orbiting Jupiter, has been going around it for the last 12 years. And while doing so, it's taking beautiful pictures and images of Jupiter. So here are some of the pictures that Juno has taken. So for example, this is a picture where you can see all those little vortex sort of rows and these storms and these sort of complicated structures in the atmosphere, which is kind of like hurricanes on Earth, right? You can see that the storms sort of go around, and it's kind of like weather on this planet, which is very exciting. And the biggest storm out of all on Jupiter is this great red spot, which you can see here in the bottom left, right? And this is the fastest and biggest storm in the entire solar system. And wind speeds are much, much, much bigger than on hurricanes. So if you don't want to go there, you would be you couldn't fly a spaceship or a plane in this atmosphere because the winds are way too strong. So here's another picture of Jupiter that's taken by Juno, and you can again see those beautiful sort of bands that go around the planet. And this picture is sort of taken half from the north pole of Jupiter. So the right side is kind of the north pole of Jupiter, and you can see that it actually changes color, which is also very interesting. And then here is some more close-up where you can see sort of the beautiful structure on Jupiter. And I think this image doesn't really, if you don't know that it's a picture of Jupiter, you would think this is sort of a picture that was taken at the beach of like water and like sea foam hitting the sand beach. So, but actually that's not true. It's a picture of Jupiter, and Earth wouldn't even would fit in that image. That's how big this planet is. And then here's my very favorite picture of Jupiter, where you can again see all the different colors in Jupiter's atmosphere and the storms and the winds and the sort of interesting flow structures. All right, and the third and final reason why Jupiter is my favorite planet is because it has really interesting moons. So there's this Italian astronomer called Galileo Galilei, maybe you've heard of him, and he is the guy who invented the telescope. And obviously, when you invent the telescope, you first want to take a look at the planets, right? And he did that, and he looked at Jupiter, and he saw for the first time the red spot of Jupiter, but also he saw 4 little dots right next to Jupiter. And he looked at Jupiter every night when there was no clouds in Italy, and he saw that the dots sort of moved around Jupiter, and he realized that those dots must be moons, right? They can't just be other more distant objects, but because they sort of go around Jupiter, they must be Jupiter's moons. Unfortunately, Galileo Galilei's telescope was kind of bad, so he couldn't actually take good pictures of the moons. But now we obviously have spacecrafts, for example, Juno, which actually flew to the moons as well. So here is the pictures that Juno took of Jupiter's biggest moons, and their names are from left to right: Io, Europa, Ganymede, and Callisto. And I think they just look so beautiful, and also, interestingly, very different from each other. I think Ganymede is the biggest moon, is actually bigger than Mercury. So it's bigger than a planet in our solar system. It's also bigger than our moon on Earth. And I think it kind of looks like our moon, but also very different. It has this sort of, black spot on the top. But I want to ask you all a question, not about Ganymede, but about Io. So here is a zoom in of Io. And the question I have for you all is, what are these sort of spots that are that cover Io all over? So please, put your ideas in the chat, and I'm curious what you all think. Here, lakes, hurricanes, water, craters. Yeah, some good good questions. Yes, I hear some correct answers. So the correct answer is actually volcanoes, right? So all those little spots are volcanoes on Io, and Io has more volcanoes than the Earth, right? Io is the most volcanically active object in the entire solar system, and that's because it's so close to Jupiter that it's sort of going around it, and Jupiter is heating up the interior of Io, which is generating lots of heat, and that wants to go out. So, and it goes out by generating volcanoes. All right. Yeah, here's again a summary. Give me 1 second. Right. Sorry. Yeah, here's a summary again of the three reasons why I think Jupiter is my favorite planet. It's the biggest, it has a really cool looking atmosphere, and it has 3 interesting moons. But what about the other planets? So I already mentioned Saturn and Earth. Here are 3 planets to scale. But of course, there's 3 other planets interior to Jupiter, which are Mercury, Venus, and Mars. And together with Earth, those 4 planets are called the terrestrial or inner planets, because they're kind of like Earth in their size. They all have are like rocky and are close in and are kind of similar, but also are different. And here are they shown to scale. So all of them are much, much smaller than Jupiter and Saturn. And then further out, we have 2 more planets, which are Uranus and Neptune. And typically those 4 planets together are called the gas giants. And specifically Uranus and Neptune are called the ice giants because they're the coldest planets in the solar system. So the question is, there is another big object in our solar system, and that's of course the sun. And now I'm gonna show the sun to scale, which I think is incredibly impressive. So this is the sun, and now to scale, it's actually about this big, right? So I think that's shockingly impressive. The sun is really, really big. Even big Jupiter is tiny compared to the sun. And you can sort of see this, big fire on the bottom of the sun here. And that's called a solar flare. And it's a big explosion on the surface of the sun. And in this case, this explosion is about as big as Jupiter. So I guess we're very lucky that the Earth is so far away from the sun, because otherwise we'd be, grilled by all the fire on the sun. So far, I showed you, my point was to show you all the sizes of these objects to scale. But what about the distances? So now the sizes are not to scale anymore, but I'm trying to make the distances to scale. So those are the 4 inner planets, sort of how far away they are with respect to each other and also with respect to the sun. And my next question for you all is, how far away would Jupiter be? So please, again, feel free to post in the chat A, B, or C. So A is kind of just outside of Mars, B is sort of in the middle, and C is outside the frame. So I'm curious what you all think. All right. Yeah, so whoever said C, that's correct. So Jupiter is actually outside the frame. So I actually need to zoom out everything to even see it. And I hope that was sort of visible here. So Jupiter comes in. I'm squishing the inner planets together such that I can even see Jupiter. And actually in between Jupiter and Mars, about halfway, is what's called the asteroid belt. And that's also a very interesting sort of setup, because there's lots of rocks in the asteroid belt which are much smaller than Earth, even Mercury, but there's lots of them. And this is probably a region in the solar system where they almost formed a planet, but somehow there wasn't enough material available, or some reason why there couldn't be a planet, and instead all those asteroids are still around in like a belt structure. So that's a very interesting setup too. But then if you go further out, we have Jupiter, and we in fact need to zoom out even more to see more planets. So Saturn is about twice as far away from the sun as Jupiter is, and Uranus and Neptune are even further away. So on this scale, right, the inner planets are barely visible anymore. So we basically have an equal spacing: Jupiter, Saturn, Uranus, Neptune, but all the inner planets are like super close to the sun, although in fact they're not they're still pretty far away, right? Of course, there's one object I've sort of not mentioned yet, and that's Pluto, which is a dwarf planet. If you have questions on that, I'm happy to talk about that more later. But Pluto is unfortunately not a planet anymore. It's a dwarf planet, but he's even further away from the sun as Neptune is. And a spacecraft would take over 10 years for this distance, even the fastest spacecrafts that we could currently build. But of course, our solar system is not everything there is in the galaxy. there's more, and specifically, there's other stars like the sun. However, those stars are way, way further away. So, for example, the nearest other star, which is called Alpha Centauri, that's over 6,000 times further away than Pluto. So a spaceship would take 60,000 years to get there. And this is the reason why, unfortunately, it's pretty unlikely that humans can ever visit other stars. We can only sort of explore our own solar system, but everything else is just too far away. But let's take a look at other stars, right? Even we can't go there physically, but we can still look at them. And in fact, everything you see at the night sky, almost everything, are other stars like the sun that are just very far away. So you can't really see them as well as the sun. And here's a picture that I found online where you have the mountains and you have this sort of beautiful shape in the middle, which is actually the Milky Way galaxy, our own galaxy where we are in. And all those little dots you see, not just in this band, but everywhere, are stars on the galaxy. So the question for you is, do you think these stars have planets too? So again, feel free to post in the chat. Yeah, I guess if you remember the title of my talk, the answer may be pretty obvious. Yes, indeed. Lots of them have planets, right? Otherwise, my talk would just be planets in the solar system and not planets inside and outside the solar system. So yeah, that's exciting. Lots of these stars have planets. And actually, that may seem obvious, but we only discovered the first planet around another star like 30 years ago. So this is a relatively new development. Before that, we really didn't know if only the solar system had planets. But yeah, lots of them have planets. So I want to show you one star that has planets, and that star is called HR 8799. Yes, that's the name of the star. It's kind of a boring name. And that star is in the constellation Pegasus. So if you find that on the night sky, it's about where the arrow is pointing. And this star is 140 light years away. So 1 light year is the distance light, which is the fastest thing in the universe, can cover in 1 year. So 140 light years is really, really far away. In fact, a spaceship would take over 1 million years to get there, right? So it took 10 years to get to Pluto. It took 60,000 years to get to the nearest star, and it would take over 1 million years to get to this star, which is called HR 8799. But again, we don't need to go there. We can just use our telescopes to look at the system. And we see, those are the stars in the center, we see that there's 4 planets going around the star. So this, I'm going to play this as a movie. And this movie was actually shot over 8 years, right? You can see in the bottom left, the time goes from 2009 to 2016 or something. And you can see there's 4 little dots, which I've highlighted in orange circles, which sort of, trace like part of a circle going around the star. And these are actually planets that move around the star HR 8799, much like the Earth moves around the sun. That's very exciting. Yeah, a very cool movie, even though it looks kind of, it doesn't look that impressive, but it's really cool, imagining that this is like a solar system, but just very far away, like ours. So yeah, unfortunately, these planets are too far away to sort of see any further, right? We can't take as nice of pictures as we could of Jupiter. But what we can do, we can think about these planets, we can, think about what we know about them and then sort of imagine what they would look like. These planets around other stars are called exoplanets. Exo comes from extrasolar, so outside the solar system. And typically, if we talk about exoplanets, we talk about the exoplanets that we've discovered so far. And astronomers have currently discovered over 6,000 exoplanets. However, we think there's much, much more out there, but they're just pretty hard to discover. So we have only discovered a few. Yeah, again, planets are too far away to actually take nice pictures, but we can draw them. So for example, here's a picture or like a drawing of the exoplanet that is called HD 154.6b, and that's the biggest exoplanet we've ever discovered. And it's 6 times bigger than Jupiter. And this planet is special because it's really, really close to its star, and it's also really, really big. So it's like Jupiter, but way, way hotter. And that's why we call it a hot Jupiter, right? And here you can kind of see how it's sort of getting all the light from its host star directly at it because it's so close to it. Here's another picture of an exoplanet, or a drawing. Again, this is not an actual picture. This is a drawing what we think this planet looks like. And this planet is called 55 Cancri E. And this planet is special because it's kind of like Earth. It's rocky, but it's way, way hotter too. So this planet is also very close to its host star. So all the rock on the surface is probably molten, like lava. So this planet is covered in lava probably, and has like it's very hot because the sun, its star is also so close. And here I just want to show this image as my final slide, where you can sort of see an overview of many artist renditions of cool exoplanets that we've discovered. And you can see that some of them may have rings like Saturn, but different colors. Some of them are hotter, some of them are colder, some of them are bigger, some of them are smaller. So it's a very exciting time to do this kind of science, because you can learn so much about all of these very exotic systems, which you previously only heard of from science fiction movies. So I think this is very exciting. But for our breakout room activity, I want us to go back to the solar system, because we have better understanding of the solar system. And I want to introduce this breakout room activity. So there's this website that's made by NASA. And if you click that link, I think we'll post it in chat soon. And then you click this sort of little solar system on the top. You see a sort of an overview of the solar system. And I want you guys to play around with that overview and try to answer those 4 questions. And the interesting part about the solar system or about this sort of NASA website, is that it actually shows you the solar system exactly what it's like right now. So I guess I can quickly do this. Give me 1 second. Yeah, so if I open this link, I get sent to this website by NASA. And if I click here, I get this overview of the solar system right now. So this is, you can see it's March 28th, 2023, and it's 6:30 p.m. So where's Earth? So here's Earth. We are right here, and currently, Venus is here, Mars is there. And you can also sort of change the angle of your looking at it. And yeah, I think that's a pretty cool website. And I think it's really cool to use this website and try to, answer those 4 questions. Yeah, and with that, I hope you enjoyed my little talk, my little journey through the solar system. And I guess we have the breakout room activity first, and then I'm happy to answer any questions. I think that's the order, right? And yeah, I hope you enjoyed my talk. Oh, I see there was a question on Make. Yeah, that's kind of hard to find, right? But there's also a search function on this website. I can briefly show. Right. Okay. So I'm currently looking at Mars, but if I let's look up Make, it actually takes me to it, right? And here's Make. And if I zoom out, I'll see it's actually, here, it's actually very far away from the sun, much further away than Uranus, Neptune, and even Pluto. And it's also a dwarf planet, kind of like Pluto. And one of the reasons why Pluto is not a planet anymore, unfortunately, is because other objects like Make have sort of the same right to be a planet as Pluto has. So the option was either to promote like 10 other objects to planets or to demote Pluto to a dwarf planet. And I guess people thought that it's easier to remember eight names for planets than like 20. So now we only have 8 planets, but a bunch of dwarf planets, which is also exciting.
Thanks so much, Konstantin. Sorry, I'm having trouble with my audio earlier, but I am going to pull a couple questions that I've been collecting throughout the whole time. There's been a lot of activity in the chat, and so I'll get to some questions that were asked earlier in the session. So one person asked, what would happen if we shot a nuclear warhead at the moon? Would the debris fall back to Earth?
Yeah, that's a really interesting question. So no, right? So the moon is not falling to Earth, right? The moon is sort of going around the Earth pretty happily for the last millions and billions of years, right? So if the moon would suddenly, explode, the debris likely would, stay where it is, right? So yeah, the moon is pretty happy there. Also, a nuclear warhead is not strong enough to destroy the moon. So the moon is there to stay. But the interesting thing is that sort of hypothesis of using, weapons to blow up asteroids has been used as like planetary defense. So, for example, the dinosaurs were probably destroyed or went extinct as a consequence of a big asteroid impact on Earth. And if that would happen again, then that would sort of destroy Earth's ecosystem again, as well as human life, and also lead to another ice age. So that would probably be something we wanted to prevent. And one way of sort of doing that, maybe if the asteroid comes, to use nuclear weapons to blow it up. But that's only one way. A probably better way would be to try to divert it away from Earth. That's probably easier to do. So yeah, but interesting question.
Okay, so I think people have our minds wrapped around what to do when something is solid, like hitting the asteroid, hitting the moon. But there's a lot of questions in the chat about the gas giants. So number one, are they just purely gas? And if they are, how do they keep their sphere shape? What about those gas giants?
Yeah, that's a really cool question. So we actually don't know if they're only gas or not, right? We can only, so what we do know very precisely, for example, with Jupiter or other gas giants, is we know their mass. So we know exactly how much they weigh, but we don't really know how that material is distributed in the planet, right? So some people think Jupiter has a core, so there's sort of like a rocky surface somewhere in the deep interior of Jupiter, but we don't really know that. So it's a very interesting unsolved puzzle if gas giants are just purely gas, or if there's some sort of core in the center of these planets. And the spherical is also an interesting question. So basically, everything, if you sort of noticed, most things, so all planets are spherical, which is sort of interesting. And if you look at, let me share my screen again. If you look at this sort of website again here, an interesting observation you can sort of make is the smaller the object gets, the less spherical it becomes. So Jupiter, very spherical. Saturn, ignoring its ring, very spherical. But if I look at smaller objects, and specifically, for example, Arrokoth, that's not really spherical anymore. It looks like a little snowman, right? So that's puzzling. And the reason for that is just gravity, right? Because basically, the bigger something is, the more it wants to be sort of close together and compact. And the most compact object that you can think of is a sphere. So if something is very big, it just needs to be compact and it's a sphere. But if something is very small or like smaller, other configurations like this sort of snowman structure is possible. So it's just gravity that makes these spheres. But again, most planets are spheres, but the smaller something is, the less spherical it becomes. And that's why Earth is also not a perfect sphere, right? Because it's rotating. It's actually like a little potato because it's spinning around. So it kind of gets squished a little. So it's bigger on the equator versus the poles, which is also interesting.
Yeah, that is really interesting. And so in that explanation, you mentioned like we know the mass of these planets like Jupiter and Saturn. And so one of the questions in the chat is, how can we determine things like that and even what a planet is when we didn't create them?
Yeah. So what a planet is, that let me start with that one. So planets were actually first discovered by ancient astronomers. So sort of simultaneously and all over the world, by I guess in Greece, but also in Arabia or in China or anywhere really, or also here in Native America, anywhere where people looked up the sky, because planets are special. They're different from stars because stars don't really move around. Stars always stay at the same spot in the sky. So if I, went to look up at night and look at a star at the same time, like let's say at 1 a.m., I woke up and I look at the star, it's always there at the same spot. But if I look at a planet, or like, for example, Mars or Jupiter, it moves around. So planet is actually a Greek word for it, which means wanderer. So all the planets are special or not stars because they move around. So we didn't create the planets, obviously, but we coined the word. So planets basically just means moves around. So, and all systems in the solar system moves around. And then the definition, the distinction between dwarf planet and planet, you're totally right. That's pretty arbitrary. So that's just that the reason is basically because we have found with telescopes, we're able to find much, much more objects than we can see with our naked eyes. So it's really a question of how many planets do I want to learn in middle school? Do I want to learn 8 planets or do I want to learn 50? Right. And I guess the second question was, how do we know the mass of the planet? That's also a great question. And that's actually surprisingly difficult to answer. And in fact, we only have very accurate constraints from it, or we have accurate information on the masses of planets only since we have spacecrafts, which can actually go around these planets and sort of see how they go around and track that. Because basically, the way you measure the mass of a planet, you look at something that goes around it. For example, we know the mass of the sun very exactly because we go around the sun, right? And we actually know the mass of Jupiter by looking at the moons of Jupiter, which go around Jupiter. And so an object that doesn't have a moon, like Venus or Mercury, is actually kind of hard to determine the Mars. So we need to have spaceships to have very accurate constraints. But that's a great question, and yeah, very interesting.
All right, I think we have time for one more question, and I saw this last one in the chat. We looked at the website. There's so many things going on, a lot of planets, dwarf planets, and we're not the only solar system out there. How have we not crashed into another planet or solar system by now? If everyone's constantly moving, like,
yeah, that's pretty surprising. So I guess there's sort of 2 answers to this question, why we haven't crashed into anything. The first sort of answer is that stuff is just really, really far apart, right? So basically, I said that a spaceship would take 60,000 years going at full speed to get to the nearest star, right? So it's just very unlikely that we ever hit another star, right? And the same kind of goes for planets. But the planets in our solar system, they actually have something that's called a stable orbit. So they go around, but the sort of, that is called an orbit, going around the star, that's called an orbit, but the sort of orbit itself doesn't change. So it doesn't just go like randomly wherever it wants. It goes around in the same manner every single time, like a pendulum. So it's very predictable. And all the planets have different sort of distances from the sun. So they never meet each other. They always sort of go around, but they go around sort of the same path. And because they're sort of kind of like an onion layered from the inside out, they never actually sort of collide each other, right? But that's only for the planets. Some other objects like comets and asteroids actually they do cross, like they have the same kind of circles, but the circles cross each other. So there it's possible that we do hit asteroids. Yeah, that again is kind of rare, but not super rare. So sometimes it happens and kills dinosaurs. So yeah.
Well, thank you so much, Konstantin, for the amazing presentation. I hope we continue to stay lucky and not have another dinosaur extinction anytime soon. But in the meantime, I'm going to pass it over to another volunteer to end this session. But thanks so much again for your time.
Thanks.
Yes, thank you so much for the great talk. And thank you to everyone who attended for asking such good questions. It's really interesting. So, as a reminder, if you've missed any of our previous talks and want to go back and see them, we have a YouTube channel. So you can follow this link and go watch all the previous talks. And then just as a quick preview for next month, our next Exploring Science will be on Tuesday, April 25th, also at 6 p.m. And Allison, who's a grad student in neuroscience, will be talking to us. So I hope that you can all attend next month.